The Berlin Airlift, a project by David Gamboa, Michael Brown, and Kenny Johnson. The Berlin Blockade was one of the first major international crises of the Cold War, a resulting action of the Allied powers attempting to create one single economic unit from their different occupied areas of Germany. It was an attempt by the Soviet Union to limit the ability of the Western Allies to travel to their sectors of Berlin. In response, the Western Allies organized the Berlin Airlift to bring supplies to the West Berlin population. Using linear programming, we can maximize the cargo delivered with the following restrictions. The Western Allies were only able to use a total of 44 planes. The Americans had a cargo capacity of 30,000 cubic feet, while the British had a cargo capacity of 20,000 cubic feet per plane. Each American flight required 16 crew members. The British only needed 8 per flight. The total number of crew members available for this mission totaled 512. Finally, the total weekly cost of this mission could not exceed $300,000, with each American flight costing $9,000 and each British flight costing $5,000. Using the variable x to represent the United States and y to represent the United Kingdom, we have a linear equation for cargo to maximize within the constraints. To solve this linear programming problem, we will use George Danzig's simplex algorithm, developed to solve the Berlin Airlift and other logistical problems. Setting the p function equal to 0 and adding a slack variable, we can convert the inequalities to equalities. The equations can then be put into an augmented matrix that is referred to as the initial simplex tableau. To solve this linear optimization problem, the pivot points must first be identified. The pivot column is located with the most negative number on the bottom row. Next, we find the smallest ratio between the last column values and the pivot column. "32 is our smallest ratio. This means that the second value in the pivot column is our pivot number. Knowing the pivot number, we use Gaussian elimination to make the pivot number equal to 1 and the rest of the numbers in the pivot column equal to 0. At the same time replacing the associated variable on the side with the pivot column variable. The process is repeated until there are no negative number values in the bottom row of our matrix. With the problem solved, the variables on the side can be associated with the variables on the side of the matrix. 20 American planes and 24 United Kingdom planes are needed to optimize the amount of cargo to be delivered within the given constraints. The problem we just worked through was a very simplified version of the problem the Allies forces faced, but the process is the same. It helped the Allies fly over 200,000 flights in 1 year and delivered over 8,893 tons of necessary supplies, such as food and fuel, to the West Berliners. At its peak, a plane landed in West Berlin every 45 seconds and was delivering more cargo than was previously being delivered by rail. The use of linear algebra helped the Allied forces to make the most of their time and money. This led to a maximization of lives saved in an already war-torn West Berlin. The Berlin Airlift was considered a massive success, even surpassing the best supply cargo transport methods at the time. On 12 May 1949, the Soviet blockade was lifted, and the airlifts continued to help West Berlin amass a stockpile of supply. Although we did not specifically learn about the simplex algorithm this semester, we did learn about the linear system A times x equals b. This is part of the fundamental theorem of linear programming, and without it, the Berlin Airlift would not have been possible. Thank you very much for your time, and we hope you enjoyed our presentation.